Hi, I'm Jay from RS Garage, and today I'm going to be breaking down this RB26. This is an engine that I've owned for a couple of years now. It was actually purchased from Javier at TRC out of his R32, and its intended use is to go into a Datsun S30 project that I have. Got quite a bit of things going on right now as I start up a new business, so the Datsun project will probably sit idle. But in the meantime, we can get through the engine. So Mark Mazurowski and I have talked about this project, and he also has an R32 that he would like a built engine for. So what we're going to do is go through the entire process of rebuilding this engine. We've got a bunch of really nice Brian Crower parts to put into it. And if Mark wants to take it and put it in his R32 at that time, he can, giving me his core engine, then we'll build that engine to go into the S30. But the main thing is to get this engine in process. So this is my first RB26, and I've looked at it and kind of walked around it and thought through it for quite a bit of time because it's always been the RB and the 2J, and I've always been a 2J guy, and I've always kind of not looked down on the RB26. It's just doesn't have the same amount of part volume and displacement and casting and deck height and a bunch of other things that make the 2JZ very tough. However, this is a very special little engine. I would argue that it's one of the best looking and best sounding engines to come out of Japan. If you haven't heard an RB26 in action, they're really, really beautiful sounding engines. They have a lot of personality, and their intended use from Nissan's engineering team was to be a circuit engine. So there are some differences in this engine that we're going to kind of look at and discuss as we break it down. But if we take a look around the engine, the first thing that you'll notice is the exhaust ports aren't stepped in like they are on a turbo 2JZ. And the factory engineering team that did the 2JZ, they needed to move those ports in to make room for the twin turbo system that they designed, whereas Nissan uses a straight port and hung twin turbos off of it, and kind of a more conventional, non-sequential operation, just a twin turbo 6-cylinder, whereas the JZ factory system was built to bring one turbo online first and then bring the second one in as engine speed increased, giving the engine more low-speed power. But nonetheless, this is a neat engine. The guys down in Australia have done a ton with it. There's some really fast RB-powered cars these days, most of them utilizing the RB30 block in its taller 9-inch deck height, which is about 400 thousandths taller than a JZ. So then you get this RB26 head on a more suitable, larger displacement capable block, and that makes a neat combination that I would argue definitely is a 2JZ competitor. This, however, in its state, I don't want to make 1,000 horsepower with an RB26. This will be a 600 or 700 horsepower engine. It'll be plenty of fun like that and make some really, really cool sounds in the process. So let's get this engine apart. We'll point out some of the differences between the JZ and the RB as we move along. There's been a lot of comparison videos done by other people. This is just going to be my take on it. So enjoy. So unlike the JZ, this is a CAS system. So they're getting the engine timing, where the crankshaft is, where the camshaft is, off of the exhaust cam of the engine, whereas the JZ conventionally would use a crank trigger and a cam sensor. Now, there are retrofit kits that have changed that over the years as people have raced these engines more, but as you get into the tuning of these engines, these factory CAS wheels are sometimes problematic. But if you're going to move to an aftermarket crank trigger, you want to make sure that it's by a reputable company, that the trigger pattern is easily recognized by whatever ECU company you're going to use, because not all aftermarket triggers are machined with the tolerances that will be readable by an aftermarket ECU. So you want to be careful in which aftermarket trigger system you purchase, and that goes for any. So taking the cam covers off, you'll notice that there are 4 large outlets for crankcase pressure to leave the crankcase. So again, I really feel like a lot of engineering went into this engine to be a competent circuit engine. So a lot of crankcase breather available, unlike the JZ from the factory. And when you pull the cam cover off, you've got a baffling system with drain back, and then they've got splash shields coming off the cam lobes on the 2 cylinders that are adjacent to where the breathers start. So they're working through oil control on an OEM level in the valve covers, which I think is very smart. You know, as you move into aftermarket valve covers, a lot of them look pretty, but they lack the oil control that an OEM system has engineered into it. So Nissan did a really good job on the valve covers, having the not only very pretty swoopy looks of them, but a lot of crankcase breather available. As we go to remove the cylinder head, you're able to take the cylinder head off the engine without removing the cams. Each cam has a relief in it that if you align the cams with the relief, you can get a tool down past the camshaft to get the head off, which is kind of a neat convenience. So you can see on cylinder number 5 that the sealing ring is distorted. So this was at the end of a head gasket. Most of the engines before the JZ that were OEM turbocharged engines had composite head gaskets. So you had a gasket with a pre-flattened sealing ring in it and a graphite core or a paper core, and that's how the head gasket sealed the engine. And this was the fuse. So if you had an early 4G63, a 7M Toyota engine, an RB26, and you turned up the boost and you made a mistake in tuning, it would blow the head gasket. And these gaskets are fairly soft in comparison to an MLS gasket. So you could just get away with hurting a head gasket. The gasket was the fuse. And as we moved into tougher gasket solutions like the MLS or fire rings or copper with a wire, you lose some of that ability to just hurt the gasket. And you'll often hear people that have a MLS gasket failure, and they'll say like, maybe it's just the gasket. And by the time you get an MLS gasket in trouble, you generally are hurting other parts. So this is kind of from the old school, where you can see in this sealing ring, it's distorted and there's some trace happening under the gasket on this cylinder number 5, where it's starting to move the gasket out of the way and connect the dots between the combustion and the water. And this is just, you know, whether they were running this engine too hard for the factory tuning or however they were doing it, they were starting to lose this gasket here. Another thing that's interesting and specific to this platform is the water flow of the engine. And this, again, going back to a circuit racing engine, the mainstay that you need to kind of implant into your head is this is just a heat management process. So when you have temperatures that are stable in the engine, whether it be the in-cylinder temperature, the oil temperature, or the coolant temperature, that's going to help keep that engine alive. And this RB engine has, unlike the JZ, a larger thermostat that is in a higher flowing situation. You have a water pump body that is thicker, and then this is where it really gets different. As the water exits the pump, it comes down this manifold that runs along the block. So this whole piece of casting is nothing but a water manifold. And then the water enters the engine and goes across the engine. So a JZ is front to back. So on a JZ, the water enters in the front of the block, goes to the back of the block, comes up into the cylinder head and out of the front of the cylinder head. This engine is way different. It's got water flowing across the engine. And then if you look at the cylinder head, instead of the JZ having an outlet on the front of the cylinder head, you have a water outlet here, a water outlet here, a water outlet here, and a water outlet here. So essentially you have a cross flow cooling system on this engine, which I have to assume offers quite a bit better pressure balance inside the engine and better temperature mitigation for endurance settings. So, you know, if you go back to where the R32 really cut its teeth with this engine was circuit racing in that, 400, 500 horsepower range. And they were just deadly cool with the all-wheel drive system and all the tech that an R32 had. Very effective vehicles for their time. Now, if you've been around the RB26 for a bit, it's no surprise that people talk about the oil pump gear and its failure. And if you look down into the oil pump, you can see that the crank snout does not have a lot of engagement. So the crank snout in its oil pump drive gear goes into the pump just a small amount. And if you look at the crankshaft, it reflects that right here, where you can see a very small amount of the crankshaft is engaged in the oil pump. So you have all this room available, but only this much is used. So you can already see some of the deterioration of this surface as it kind of lays over and is worked over by driving the pump over the miles that this engine has on it. With the engine flipped upside down, you can see that there is a integrated main girdle. So the main caps are tied together by this cast piece that essentially is a girdle. So if you go from there are a few different types of engines. There are engines that have short skirts. So these will be the skirts of the block where the main caps are hanging down out of the block. And then you have a deep skirt block that the skirts of the block are about level with the main caps. And then you get into integrated girdles like this or the later 4G63 engines and a handful of other engines out of Japan. And then you move into bed plate like a K-series where the engine is split at the mains, where the pan and the caps and the girdle are all one piece. So, for the early 90s, this is a pretty advanced approach to try to stabilize the crankshaft. Now, being a guy that has a large amount of experience with the JZ engine, these parts are pretty small. So when you look at that connecting rod, it's just a short little fella. It does have an integrated jet coming through that's oiled through the rod bearing that's squirting up on the cylinder wall, along with a piston cooling jet like you have in the GE. However, and Mark Mazurowski pointed this out to me the other day, there is a channel in this piston that the oil jet squirts oil directly up into this piston. So it's not a spraying oil on the bottom of the piston. They have a precise location that they're trying to land that oil, and it's in a cavity that's behind the oil ring, which is pretty neat. There's a vessel, that channel that allows oil to get up in there and try to cool that piston off, again going back to the circuit engine. Now, I mentioned earlier that the number 5 cylinder was starting to move that head gasket out of the way, and at the same time you've got some damage going on at the bearing. So if you look right here at 12 o'clock where the bearing has started, this is the upper rod bearing, where it started to wipe, the oil has been displaced and it's starting to wipe that bearing out. So, you know, detonation, it's not just the head gasket, it really rocks the whole engine. So when you start to rattle a cylinder, there's enough cylinder pressure in the cylinder that you can displace the oil and kill a bearing. If the bearings are soft, you can flatten the bearing out, just pound it flat. You've got guys out there that are able to elongate the pin bushing and the connecting rod, and then just a host of other problems. So detonation is not going to be just that head gasket. It really rocks the entire engine when you have out of control 3 to 4x internal cylinder pressure going on in a cylinder. You know, cracking sleeves, all kinds of bad stuff happens. But this rod bearing is in tie with that failing head gasket. Another thing to consider with an OEM approach is how the engine will live if it's not misused over its lifespan. And the OEMs are able to use a very soft bearing material that when you take apart an engine like this that has, you know, somewhere, you know, tens of thousands of miles at a minimum. You know, this is not a low mileage engine. And you look at the crankshaft finish, and the crankshaft finish is very nice. There's very little deterioration of the crankshaft finish, and that's because the bearings take the blunt of the abuse. And these bearings are soft. If I take my fingernail and dig into this bearing, I can scribe this bearing up with just my fingernail, and that's how soft they are. But they're kind of sacrificial. If you don't misuse the engine and you're not making tremendous amounts of cylinder pressure, even though the bearing is soft, unlike a race bearing, it will live its term. Now, as you get into race bearings, you know, you have to understand that there will be more wear present on the crankshaft, but that bearing is going to be stronger and harder and tougher when it comes to the tuning mishaps and hard use that a aftermarket tuned engine is. You know, the factory, when the factory designed this engine and tuned it to work at the factory power level, all these parts were a system. And when you start going outside of that system, you know, there's compromises that are going to happen, you know. So just like this crankshaft, when we get the crankshaft out on the bench and we compare it to the Brian Crower crankshaft, this is not a fully counterweighted crankshaft. They sacrificed durability for weight, you know, because again, circuit engine. And you want in a circuit racing environment, you know, less rotating mass internally can mean a faster accelerating engine when you come out of a corner. So a lot of decisions were made in this engine that were based off of how it performed on a racetrack. So I know that there's a handful of us that have taken a lot of engines apart, and when you take the main bolts loose, there's generally a stench that kind of like exits the bolt cavity, I think the Nissan smells different. It's kind of tangy. It's got like a less dead smell to it than the Toyota. It's kind of weird. Comment below if you know what I'm talking about. Oh, look at this little cutie. You know, for years I was racing the JZ platform, and you know, Mark Mazurowski and I, we've been buddies for a while, and I would go to his shop and drop stuff off, and he would machine it, and I'd put it together, and we'd go back racing. And then one day I saw one of these things at his shop, and I said, "What's that?" And he said, "That's an RB26 crank." And I was like, holy moly, it is so small compared to a JZ part. It really blew my mind that that such a small part was put to use in an OEM turbocharged engine, because the material is a lot of the ability to handle abuse. You know, generally the more material an engine has, just in raw casting material, the tougher it is, because it's got more cast iron or aluminum to handle the work. And this crankshaft is it's pretty small, pretty lightweight. As we move into the bottom end of the engine, you can see the factory oil squirter that I was talking about. You also have a main bearing that not only is a grooved main bearing, but it has multiple inlets for oil to make itself available to travel down the crankshaft. Because remember, the rod bearings are getting fed through the main bearings. So there's a full groove in the block, and then along with that you have a bearing that has multiple oil inlets to fill this channel or reservoir to make the oil available to the rod bearings and the main bearings. So taking a look at the factory piston pin, it's 826 in diameter, so it's smaller than the JZ's 866, but it's a pretty substantially beefy part. It is just over 2.7 inches long, so it's a wide pin to help stabilize the piston, and it's a double taper pin. So the section of the pin that is in the connecting rod is around 200 thousandths thick, where on the outside it's around 120 thousandths thick. So they've kind of tapered the internal thickness of the pin to shed weight. So, you know, it's not an inexpensive machining process, and there are some exotic pins that you can buy through the aftermarket like this, but this is an OEM part. And, you know, again, they were aware of reciprocating mass, so they needed a certain amount of strength in the pin so it would live in the part and help stabilize the piston, but they wanted to shed some weight in the process, so they added some tricks. One thing I can say, the RB26 definitely looks like it lacks is oil drain back. So as you move down the engine block, you can see that there are these small holes. They're smaller than 3/8 of an inch, and in the back you have two pretty cavernous holes. But you know, you're pumping all this oil around in the engine. It needs to get back to the pan in order to get back into the system and be pumped back through the engine. It's just going in a circle. So I would say that these engines lack drain back compared to a JZ. And they also, if you look at the size of the feed for the pump, it's quite a bit smaller. You know, the JZ has a fairly robust oil system. So you look at the size of the hole in this block compared to a JZ, it's a pretty big difference in, you know, getting the oil to the pump, getting the oil out of the pump. You know, the oil outlet on this engine that's going to go down the mains, it's quite a bit smaller than a JZ. So, you know, again, it doesn't have the robustness of the 2JZ, but doesn't mean there isn't a lot of fun to be had with an engine like this. So one of the upgrades this engine's getting is this Brandauer crank. It's a billet, fully counterweighted 79mm stroke crank, and it's full of all of the goodness that Brandauer puts into its crankshafts. This is my brand of choice when it comes to crankshafts. I just have a kind of a loyalty to the product due to the finish work and the strength of the component. So I don't have to look elsewhere. When I need a nice crankshaft, I can just go to BC and get what I need. And right down to the finish work, the sizing, everything's always right. It's going to replace the factory 73 and change millimeter stroke crankshaft we have here that has the short oil pump gear, and it is not a fully counterweighted piece. As far as the connecting rods go, got a Brian Carver H-beam with an ARP625 bolt. These are fairly short rods in this engine, so not really prone to breaking a rod like you would in a longer rod engine. The BC rod is actually lighter than the factory rod, coming in at 540 grams versus the factory 622. And again, ARP 625 rod bolt, much stronger piece than what was in the OEM component. Thanks for tuning in for this video. Going into this RB platform, it's a bit exciting for me because the RB26 has always been the other Japanese turbo 6-cylinder, and now I get to tinker with them. So we're gonna take this engine all the way through. It's gonna have a ported cylinder head, single turbo conversion. I've got a precision turbo for it, a plasma man intake manifold. It's going into that iconic Datsun S30 chassis, which is just something, you know, kids of my era growing up looking at that car, it's just a really neat little sports car. And again, it doesn't need to be terribly fast to be fun, but it's gonna be a good running, good sounding little hot rod. So thanks for tuning in. We'll see you next time.